Hello and welcome to WindFarmer Educational. So the question we're going to deal with in this tutorial is how can you calculate the energy yield of a wind farm when you don't have any actual measurements of a wind resource at your site. I'll show you how you can make an energy assessment using the energy results of neighbouring wind farms, and this is a common practice in Germany and it's increasingly useful in other parts of the world. So here's a WindFarmer workbook I've prepared for this demonstration, and the location is the northwestern part of Germany. This is the town of Leer, this is the Autobahn, and this is the River Ems. You'll see that there's a total of 4 wind farms in my workbook. Here we have Project Leer. This contains 8 Vestas. Then we have Project Bunda with 13 GE turbines, Project Driva with 8 Enercons, and in the centre you will find the wind farm that we're planning. This has 8 Nordex N60 turbines. You may also notice that the hub heights for each of these wind farms differ. I also want you to take notice of the difference in the colour between the turbines. So our proposed turbines are shown in green here, and the other 3 projects we have turbines pictured in blue. This blue colour indicates that the position of the turbines are fixed and that they're installed and connected to the grid. And I can show you that by just selecting one turbine. I right click with my mouse and bring up the Turbine Properties. So in this tab you can see that the turbine was installed in 2002 and the annual yield is around about 5720 megawatt hours per year. I was able to retrieve the production data of this turbine from its SCADA output, and along with the production index I was able to upscale the data towards an average annual value that you see here. I don't want to go too much in depth on this method of upscaling, but if you want to learn more on production indices, I suggest you follow the URL. So along with this production yield, you'll also see a confidence weighting. Now this value is actually less scientific and it's more related to the experience of the person doing the energy assessment. In this case we have a 20-metre difference in hub height between the wind farm in Leer and our proposed turbines. I try to reflect this difference in my confidence weighting and also back in my energy calculation. Or to put it differently, increasing or decreasing the confidence weighting implies to what extent you incorporate the production yield of your installed turbines in your energy calculation. For our calculations we'll make use of a Wind Atlas file from WASP. So I open the control panel and select it. The lib file I used here is based on years of data from a measurement of a Synop station in Leer and is representative of the wind characteristics for the site of this workbook. With this lib file we'll now calculate the wind resources for the different hub heights that we have in our workbook. And I do this by adding a metmask to my workbook and opening the Wind Studio. I make sure that my metmask is also available for other projects. And now I configure my wind resources. You'll see a whole list of wind resources will appear down below. We're almost set to do our calculations, but before that I'll again open the control panel to provide you with a little bit more explanation here. I want you to concentrate on this value here. It's the calibration factor. Even the most sophisticated flow models will need some calibration through measured data. We just saw that the measured data in this case is the production data we got from our existing wind farms. WindFarmer will calculate a calibration factor based on the lib file, the production data and the confidence weighting of the existing wind farms. At this stage we haven't done any calculations, so I won't change it. I'll apply the default value of 1. I now browse to the Energy tab and select Also Calculate Energy for Only Installed Turbines. And selecting this will imply that I actually do my calculations twice. One calculation will be for the installed turbines. I need to make sure that only the wakes of the existing turbines are considered when I try to retrieve the correct calibration factor. The second calculation will be for the installed turbines plus the proposed turbines. By this I'll also include the wake effects of the new wind farm on the existing wind farms and vice versa to retrieve an accurate energy yield for my proposed wind farm. So now we're ready. I press T to start my calculation. And if you pay attention, you'll see the progress bar down below showing that we're actually calculating twice. And ready. Here we have the results. At this stage I'm less interested in the yield but more in my calibration factor. I'll just enlarge it a bit to show you this information with a bit more detail. So if you remember, this is the default value of 1, and over here we now see the value that WindFarmer calculated based on the production data. When I now apply this value of 0.984 to my lib file, I come really close to the production data that I set for my existing wind farms. And when the calculation is run for a second time, I get the energy yield for my proposed turbines. Let's insert it. I close this screen and open the control panel. I go to the flow model and insert the value here. Then press OK and run another energy test. And here's the result. I'll enlarge it a bit so you can see that the values now are matching. So what I have inserted is equal to what was calculated by WindFarmer. Now when you do this yourself, it may be that you'll have a small change in the decimals between the two values. This just means that you have to again fine-tune your calibration factor and insert this value back into the control panel, run the calculation again until they finally converge. If I scroll down to line 80, you'll see the estimated yield for our turbines is 18.7 gigawatt hours per year. So based on the production data, which I upscale to long-term data in a lib file, which represents a long-term wind flow climatology, I was able to build a model in WindFarmer that I could calibrate and use to estimate the yield of a future wind farm.